the reason that I want to show you how to use OpenStreetMap to get data from them is that, first of all, I think this is a good opportunity for us to get some practice, more practice on Python data. Okay? So also, aside from that, we get also some experience on how to get data from API services. Right? And OpenStreetMap is actually a very useful API service. So basically, the idea is that it's something like a cloud service, right? You have data in their server. And for various reasons, let's say we want to develop an app that make use of their service. Actually, there's a lot of companies that relies on OpenStreetMap API services. For example, I think Snapchat, Facebook, and they all rely on, even Uber, they all rely on their mapping services to get information, to get geographic information to support their app. So the key idea is that we're going to develop a program, a script for an app, and then whatever we do, we'll be focusing on how to communicate with the remote server of OpenStreetMap. It's a free service as long as you don't use it too heavily. But the focus is that we want to use Python codes to send queries to this API service to fetch data. Okay? So the specific task is to get data based on search result that we want to send to the API service. Okay? And this particular API we're going to use is called Overpass. I mean, the name doesn't matter too much, but this Overpass API exactly get us what we wanted. So we're going to think about what kind of information we want to search for on OpenStreetMap. And then using Python codes, we're going to send that information to the server, and the server will deliver with whatever we may be interested in. Okay, so that's the main idea. Questions? So, two key steps for us to implement the code. First of all, we're going to come up with a certain area of interest. Let's say city of Hamilton or city of Toronto, right? So in this example, we're going to focus on city of Toronto. And then within Toronto, we want to search for something that may be interesting. For example, in this example, we're going to search for cafes, right? Coffee shops. And then the mapping service will give us a list of data points on different cafes in the city of Toronto. And then we want to create a meaningful data set from whatever result is going to be returned by the API service. Okay? So that's the main idea. And let me directly present the query we're going to use for accomplishing this kind of tasks. Okay? So this is actually the query we're going to use. Don't worry too much about it, but this is not something not actually related to Python language, but it's more like a query format required by the API service. Okay? So we can look at it, but there's no need for us to memorize anything, right? So next time you want to do some similar task, you can just copy and paste and then make some necessary changes. This is exactly what we are going to do in today's class if we have time in one exercise. Okay. So we're going to define a string. Right? It's a multi-line string. I mean, if you want, you can include everything on one single line, but it's going to be looking kind of messy in the Jupyter Notebook. Right? That's why we use the 3 quotation marks to define a multi-line string. And the string is going to be stored in this variable called query. There's a bunch of things inside this query, but the important thing, is not to memorize those elements. Instead, we can try to look at them to develop some ideas about what we are asking in this query, right? First of all, out is JSON, meaning that we are going to get the data in JSON format. Okay? And then timeout 25, it means that we're going to wait for 25 seconds for the server to respond to us. Right? If the server is not responsive, which sometimes happens for various reasons, maybe an outage or maybe maybe we don't have good internet connection, and then it will time out, right? And then we get an error, so we cannot proceed. That is not ideal, but it happens. And there's something inside the third line of this cell block. So this is something like a large number representing the ID. What I can tell you is that this number represents Toronto, city of Toronto. Okay. So how do we get this number? Well, you can either search in Google or ask generative AI, or using another API. So you define a search. Let's say we're searching for Toronto or Hamilton, right? And then another API by OpenStreetMap will give you this number. For now, we don't worry too much about that number. Okay, so we just need to keep in mind that this number gives me Toronto. And in our exercise, again through GitHub Classroom, I will show you some codes. Again, you don't have to dive too deep into those codes, but then the codes will show you how we can actually get the ID for a particular place or location you want to search for. Okay, so now this ID is for Toronto. And down below, we actually define what we want to search. Right? So what we can see is that we have 3 different types of elements we may be interested in, way or node or relation. Okay. So every element in OpenStreetMap basically represents a location, a place. Okay? And the place can be a node. A node is just a point on the map. Right? So it's a single point, and that's a node. A way is a bunch of points, and you connect those points with lines. It doesn't have to be something like a line segment. It can be a line segment, but it doesn't have to be, right? So, for example, if it's a segment of street, and then that's a line segment. But it can also be multiple points forming a polygon, right? So, for example, a square. If you think about this building, this RGC building, right? I think it's a rectangular shape. Right? On the map, possibly, I didn't check, but possibly it's represented by a rectangle. Okay? So rectangle or trapezoid or triangle or all the different kinds of shapes, they are considered as a way. Right? It's basically lines connecting points. And relation is actually broader. Right? If we think about McMaster's campus, inside the campus there may be different points representing different locations, different buildings. Right? There may be also ways, which is different kind of shapes of building or stadium or parking lots. Right? So relation is basically a larger set of elements grouped together representing a certain organization or location. Right? So we need to consider all of those 3 different situations because we don't really know how OpenStreetMap actually defines a cafe, right? It can be a node, a point, right? Or it can be a building, like it's a square or rectangular shaped building, or it can be a relation, but it's not going to be very likely to be a relation because cafes are relatively small, right? Universities or a neighborhood, those can be relation, but those are not very important. The more important thing is that we need to tell the API what we want to search for, right? And as you can see, I'm telling the API that I want to look for the cafe. So I'm defining amenity equal to cafe. Right? So it means that I'm looking for some kind of amenity and the type is cafe. Okay? So not necessarily that we always use amenity equal to something to define our search. But for now, let me first run it and I'm going to explain what other kind of searches we may define in a similar way, right? So right now I haven't done anything. I just define a string, which is the query I want to send to the server, right? And if you don't fully understand the format or the meaning of the query, that's okay. I won't say that I know it that well, right? So it's just that something we need to use, we can use. Okay? And the output, this final line in the string is that we need to get the center. That's the coordinates of the center location of that structure, right? A building, a swimming pool, or whatever. And tags, the tags will be containing many meaningful information about the search results, right? Anyways, for now it's okay. It's already included in the notebook. You can just run it to see how we can use that query to do communication with the server. Okay, so if we run it, I think it will go through without many problems because we are just defining a string. Okay, so here I explained that this number, this ID represents city of Toronto. For Hamilton or other cities or neighborhoods, you need to use a different ID. Now, coffee shops like cafe or other places like school, parking lots, washrooms, those are considered as amenity. If you want to search for parks, green spaces, playgrounds, sports fields, usually they're considered as something leisure. So basically, if you do leisure equal to park, and then you can search for all the parks within a certain city or certain geographic area. Okay? Like if you use the tag land use, it may be something like woods or forests. Right? So the idea is that whatever we have in mind, we need to check with OpenStreetMap servers to see how they actually are dealing with it. So you can go to their website, or you can simply ask ChatGPT to get the information. Okay. So for now, we focus on cafes, right? And then cafes are considered as amenities. So we're going to use amenity equal to cafe to define our search, and that's everything we need to keep in mind for now. So those are the questions regarding how we can find the ID of a certain area, and we'll worry about that a bit later. And for example, dance studios, are they leisures? Are they amenities? And that's something we also need to worry about. But for now, where we don't spend too much time on that, but just keep in mind that you can always search for the type of the facilities you want to search for whenever you want to use it. Okay. Now, we have defined a query. The next thing is that we want to send the query to the remote server. So something I think we used very quickly last time. So we're going to use the requests library. Those are internet requests. Right? We go to the internet to communicate with the server. So there are two main functions, requests.get and requests.post. Request.get is to fetch data from the server. Requests.post is to send data to the server. But usually it's the case that we need to both send some data and get some response, right? So my understanding here is that here, because we have a query, we have some detailed information to pass on to the server, so we're going to use the request.posts. So we're going to send the data to the server. Of course, we're also expecting some response. Okay, so that's about the request library. What do we need to provide in order to send a request? Usually includes the location of the server, represented by URL. And the data, the kind of data we want to send. In this case, the query. We want to send the query to the remote server so that the server will understand what we are looking for. Okay? And then usually a timeout period. So if the server is not responsive, we cannot just simply wait forever. Right? So we specify how many seconds we're willing to wait. So this is actually the next part. So I think I may have the wrong notebook, but it should be okay. So let me just quickly open the other blank one so we can develop things together. My apologies for that. But it's the same thing, okay? So those are the things we have, not this one either. So allow me just one moment. Here it is. And those are the contents we have went through. And let me run the query again. And we're going to send the query to the server. Okay, so we're going to send the query to the server. And to do that, of course, we need to import requests, the library we want to use, to send the information to the server, right? And we need to define the URL. So let's say overpass equal to a URL. I think I've included somewhere or not. Anyways, so let's, if it's not included, let me just type it. It'll be slower, but it's gonna work, I think. So HTTPS column / overpass API .de. The server I think is in Germany, so it's DE, and / API / interpreter. Okay, so that's the URL we want to use, and that's just provide the location of the server so that we can send the query. Okay. Now we're gonna do R to represent the response provided by the server, and requests.post. So where do we post? What's the URL defined by this overpass variable we just defined in the line above. Okay. And then the second element will be what kind of data we want to send. So data equals, and usually we use a dictionary format. So the key is data, but what is the content of data? It's query. And query is the variable we defined earlier that gives overpass, the information, the request of the information, right? So that's the multi-line string we have defined just a moment ago, right? So timeout, let me enter maybe 30 seconds. Or you can choose a different, if you're willing to wait for longer, you can define 60 seconds or 90 seconds, right? So anyways, so let me try to run this cell, and hopefully it will be okay. So there's no error, that's great. What we have done is that we are defining the server URL, and then using the request.post, we go to the remote server and tell the server that the data I want to give you is defined in the string variable query that we defined earlier, and timeout is 30 seconds. Okay. So the next step. So what is the next step? We send a request, right? So before we do anything else, we want to make sure that the request was successful. Sometimes it isn't, and we want to figure out why, right? So how do we do this? Here we're going to just do something very simple. So we're going to do R, which is the request we sent, and run it. Whenever it says response 200, it's a success, right? 200 is success, and 400 series will be a failure. Okay. So or if you want to make it more intuitive, you can do r.status code. So that tells you the status of your request, which is 200 if it was successful. Okay, so it's 200. Questions so far? Now, the request is successful, and the response is defined as the variable R. If you want, you can use res or a response, the word response, whatever you want to use. Okay, so we are interested in what kind of results are included in the response, right? So if we do R, as you can see already, nothing was there, right? So what we can do is that we can do r.text, because whatever we get usually is textual information from the server, and we can do that. Well, it's a bit messy, but it's there, right? As we can see, we did get some information from the server. And if you look closely, it looks like something like a dictionary, right? Because we have curly brackets, we have columns separating key and values So whenever you see something that looks like JSON data or dictionary, we're going to use r.json, this function, that's typically attached to any response from an internet query, right? So, and that will give you a more clean view of the result. And let's run it. I mean, actually, it's not surprising that we're dealing with JSON, because in the query, we requested for the output to be JSON data. Okay? Now, this is the JSON data we get if you use r.json function. Well, it's much cleaner this time, but still, if you keep scrolling down, I mean, it's very long, but this is kind of expected, right? Because we're searching for cafes in Toronto. There are many cafes in Toronto. But if you look closely, the first few elements of the dictionary is not that helpful. It's not that informative, right? For example, version 0.6 and generator through the overpass API, that's just the information about the API itself, right? And there's some timestamp telling us, showing us when we made the query, when we get the result, and the copyright information as well. And what starts to have meaning is actually from the element, right? Inside the dictionary, there's a key called elements. And the value of elements is a list. You see square bracket, that's the start of a list, right? And what's inside the list? Well, it will be dictionaries inside the list, because we are dealing with JSON data, right? So we have a list of dictionaries. Each dictionary is a data record. That's something we have seen last time, right? So starting from elements, that's when things become more interesting, right? So what do? So I'm gonna first define r.json, all the JSON format information from the response as a variable called data. Okay? So now from that point on, data contains everything. Right? You can preview the data, but it's going to be very long, sometimes make your browser very, very sluggish. Okay? So next, we're going to focus on the elements part, right? So basically, it's a dictionary, but there are some less informative elements we mentioned regarding the API itself and the copyright information, but we're more interested in what kind of places we have after we send the search for coffee shops, like cafes. So we can do data, that's actually, a dictionary, right? As we have seen before, if we use square brackets and include the name of one key, we can get the value of that key. Now we're interested in getting the elements. There's an entry called elements that contains data records of all the different cafes in the data set, right? So we can do this. As we can see, it will give us a JSON format data set, which is a list of dictionaries, okay? That's one way to do this, but I'm going to change it to a slightly different method. Instead of data square bracket elements, that's the usual way we introduced before to get the value based on the key. So this time we're going to use an equivalent method, even though there may be some subtleties, and I will explain that in a moment. So instead of using square bracket to get the value of a key, we use the get function. So data.get and the key value. This will give us exactly the same result, and let's run it. Okay? It's exactly the same result, but what is the difference while we're using this? Anyone knows what may be the difference? If you use a square bracket, and then the code is going to look for the key you provided. Right? If the key does not exist, you will have an error. However, if you use the get function, if the key does not exist, you don't get an error. Instead, you get a missing value, right? So let's try to see. So elements is indeed one key, right? So however, let's using something strange. Let's say, how about something called location? I don't think there's a location key here. right? So what you get, there's no error, right? So I basically, it's empty. So whatever you get is something empty. There's no error. However, if you do data square bracket location, because there's no key card location, you will get error, right? So that's the difference. And if let's revert to the get function, let me try to see if we print it, what happens. None, right? It's none, because there's no key card location. Anyways, so let me change it back. So we're gonna get not location key, but elements key, which contains many different places that represents cafes in the city of Toronto. And then we're going to, so this is the JSON data containing all the information regarding different cafes in Toronto. So let's give it a name, give the results a name. So let's call it places, okay? So because it's a bunch of places which are coffee shops, cafes in Toronto, okay? Now, I have done this. So let me move around the comments a little bit. Okay? And then if you want, you can visualize the places. That's something we get from the remote server through the API service. From that point on, we're dealing with, again, JSON data, right? So list of dictionaries. Each dictionary represents a data record, which is essentially a cafe in this example. This is a very long list. I think thousands of cafes in Toronto. Basically, everything that is labeled in OpenStreetMap is included. Now, the next step is that we're gonna maybe sample a couple of elements, right? A couple of cafes inside that list, just to get a feel of how the data looks like. So we have places, that's the list of cafes, list of dictionaries. Each dictionary is a cafe, right? So let's do place 0 to look at the first cafe, and we get a dictionary, not surprisingly, right? And bunch of information available there. I have extracted from the notebook and included in the slides. And hopefully this is actually something a bit more clear, right? So we have key value pairs. So we have the type of the first cafe being a node, which is a point on the map. Okay? We have the ID of that cafe, lat and long, the latitude and longitude of the geographic coordinates of the cafe, right? That pins down the location of that cafe, right? And what's interesting is the key tags. It's a nested structure, so tags include many attributes of the cafe inside another dictionary, right? So amenity cafe, that is exactly what we look for, right? We said that we're looking for amenity that is considered as a cafe, and the brand, from the brand key inside tags, we see that it's a second cup shop, right? In the data set, we have all sorts of cafes: Tim Hortons, Starbucks, and many other coffee shops, right? And a bunch of other information. Some of the attributes may not be that clear, and that is okay, right? Cuisine, it's a coffee shop. A name, same as brand, it's a second cup coffee shop. Does it provide takeaway services? Does it provide wheelchair access? Right. So that's basically corresponding to the information about a cafe. Right? And then later on, we're going to extract all those pieces of information and organize the whole thing into a data frame, as we always do. Okay. Now let's sample another point inside the data set. This time, let's check the last element, last cafe in the list. Right. So -1 meaning that we're looking for the last element in the list. Right. So let's see. Similarly, it's again a dictionary with different kinds of attributes. However, if we move between those two cafes quickly, there are two dictionaries, right? what do you see? What is the fundamental difference? What is the main difference? So this is the last cafe. It's a bubble tea shop, right? And this is the first cafe. It's a second cup shop. So what's the difference here? Any quick observations? That's actually something we mentioned before, right? We said places or locations from OpenStreetMap can be either a node, which is a point, or a way, that's basically a shape created by connecting different points on the map. Or more generally, relation, which is more complex, right? It may contain ways and nodes inside it. So the first coffee shop, the first cafe, is actually a node, right? And the second cafe is actually a way. So they're different types of elements, right? So basically, something smaller is usually represented by a point, right? I don't particularly define the shape. And for OpenStreetMap, the information is contributed by not entirely by companies, right? Sometimes they're contributed by users on the internet. So it's really up to how they define those elements. So, and the last element in the list of places is way. So it's more like, it's not just a point, but it's actually telling you about the shape of the building, right, of the place as well. So as you can imagine, usually that's a rectangle or a square. Okay, so the information provided, well, it will be similar, but not exactly the same, right? So keep that in mind. That this will create a slight complication for us to convert the JSON data into a data frame. Okay, so let's move on to the next part, and this is the contrast between the two elements in the list, right? Two cafes, and the main thing is that there are different types. One is a node, the other is a way. So different types representing the same kind of business. All right, so here are some more detailed explanation on those three different elements for OpenStreetMap. A cafe can be either a node or way, and this is indeed the case in our data set. Okay. Now, we're going to construct a data frame from the JSON data, places. Places is basically a JSON format data set. And here, we're going to try to use a very simple approach. First, let's import pandas because we're dealing with data frames. Usually we need pandas. Import pandas as PD, right? Now, we do pd.dataframe to create a new data frame. But how do we create it? And this time it's not actually from a CSV file or JSON file directly. Instead, this variable places is already a JSON format data set. That's a list of dictionaries. So we just do pd.dataframe with the input argument being the variable places. That's a list of dictionaries. And we can already create a data frame. It doesn't look too bad. However, as we scroll, so what do you see? What is the main observation here? What is something that is not looking so nice and something we want to do some cleaning for? So what do you see? Some missing values, right? And not only we need to observe that there are missing values, but it will be helpful for us to understand why we are actually having those missing values. Okay, so let's go back to those two different types of cafes. Right? So let's say the first and last element. First is a node. As we can see in the dictionary corresponding to the first cafe, we have lat and long, latitude and longitude to represent the location of the cafe on the map, right? They are directly provided as key values. Right? So they are directly key values. In contrast, for the last cafe in the data set, the type is way. Instead of directly providing you with the latitude and longitude, what we have is something called the center, right? Because it's a shape, and it's a particular shape, usually a rectangle or a square for buildings or coffee shops, right? So basically, it's a shape, right? It's not characterized by the latitude and longitude coordinates directly. Instead, what this approach does is to provide us with the center point of the shape, right? Any shape has a center point, so the center point of the coffee shop building is represented by this key called center. And then the value corresponding to the center key, then this time it includes the coordinates, right? Latitude and longitude. So latitude and longitude is not directly available as keys. Instead, they are the keys inside a value that is a dictionary. And so this is a bit of a nested structure. So if you are directly converting all those records to rows in a data frame, what happens is that for places like the first coffee shop, which is a node, right, we have columns available as lat and long, latitude and longitude. So that's why if you go back to the data frame we created, right, for the nodes, we directly have lat and long, latitude and longitude. Right? Instead, it doesn't have any center attribute, right, because it's just a point, right? It's everything. And there's no center keys in this first coffee shop or any other coffee shop represented by as a node or a point. Right? And if you look at the places that is having the type way, like the last coffee shop, right, it does have a center attribute. So there's a center column which contain the geographic coordinates information, right? But it doesn't have directly information for the lat and long column. Right? So that's why we see missing values, because when we are converting the JSON format data into a data frame, right, the two different types of dictionaries as data records in the data frame, they don't exactly have the same columns. Right? Some directly have lat and long, and some actually only have the center information with the latitude and longitude information hidden there. So that's the main difference. Okay. Questions? All right. So want to clean up a little bit. So how do we do that? How do we clean up the data set so that we get rid of the nested structure, and for every cafe we want to have the coordinates, latitude and longitude? How do we do that? It's somehow less direct, as we can see, but it's not super complicated. So let me quickly explain how we're going to do it. First of all, let's say we're interested in a subset of information pieces in the data set, right? Because there are really different information included under the tag key for every data record. But let's say for now, I want to get, for each data record represented by a dictionary, I want to get the type and ID and name of the coffee shop, and the geographic coordinates and type of cuisine, and also the brand. Is it Starbucks or Tim Hortons or other type of businesses, right? So let's try to extract only those pieces of information from the JSON format data set, and let's see how we can do that. So I mean, an easy way is that to let Gemini handle it. You can say, okay, so create a data frame based on those attributes I want to get from the JSON format data, and Gemini will do it for you. But here, let me just quickly walk you through this procedure so that we have better understanding of what's going on. Okay, so let's take, for example, the first cafe in the list, right? On the right-hand side, I have the dictionary. We have different attributes, right? So what we can do here is that we're gonna just extract the information of interest one by one, right? So how do we do this? For example, I want to get, for example, type is something I want. So basically, I can use a Python command to get type, right? Type is the key. So I'm going to do place. I mean, let's say one. Later on, we'll see what we can call one record in the places list. Let's call it place, right? And we can do place.get the key of type, and then the value is gonna be the node, right? So then ID, and then that's the same, exactly the same kind of approach, right? So let's say the dictionary is called place, and the place.get ID that gives me the ID of that place, of that business, right? Of that coffee shop, right? And then same thing, we can a bunch of information is hidden on the tags, right? So I want to first get the information included inside the tags entry, tags key, so place.get tags. And that will give us the whole block as a dictionary that contains information such as brand and name, cuisine style, etc. Right? So once I define this tags variable, I know that it's a nested dictionary with several pieces of information we are interested in, right? So what do? If we have tag extracted as a dictionary, we can do tag.name to get the name of the coffee shop, tag.get cuisine to get the cuisine style of the coffee shop, right? And then we can also do tag.brand to get the brand, okay? So that's just somehow a relatively manual approach, right? To get the pieces of information one by one. And then what we can do for the lat and longitude part, it's actually the same because it's the first coffee is a node, right? We just need to directly use places.get lat to get the latitude, place.get long to get the longitude, right? Place is the whole dictionary representing the first cafe, okay? And then once we extract all those information, we can define a new dictionary, right? So it's type. What is the type? Type is node for this place. Right? What is the latitude? It's 43.67 based on what we have extracted from this first entry of the list. Okay? And what is longitude? Well, we just take the result value that we extracted from the same dictionary, right? So it's a bit manual. We just look into all those information contained in the first dictionary in the list, and then we manually extract everything, and eventually we can construct a new dictionary, and the new dictionary is going to be used as a record in the target data frame we want to construct, right? And that's about constructing a record based on each of the rows, right? Each of the data records. Any questions? Now, let's move on to the last data record. The type is weight, which is different, right? Because there are two different types in this whole JSON format data set, right? So the procedure is largely the same. Just look at the dictionary representing the last coffee shop and look at the key values, extract the value corresponding to each of the key, right? And the only difference is that now, when I'm trying to extract the coordinates, we cannot directly extract it from the keys lat and long because they are not directly the keys of that outer level dictionary, right? So instead, what we want to do is that, first of all, we get the whole bunch of information under the tag key. Everything is here for the second type of cafes in the data set, right? So once I get tag, there's a little bit of a error here, but that's a good opportunity for us to highlight this, right? So we do tags, actually the tags is actually the whole bunch of information we extracted under the tags key, and tags.get latitude and tags.get longitude, and then we can get the lat and long values as the coordinates of the location for the cafe, right? And then once we extract all the information, we'll put them into a new dictionary as a record for the target data frame we want to construct, right? So that's the whole high-level idea. If things are still a bit cloudy in your mind, that is completely fine. But if you you only need to know that we look at the detailed data record representing a particular coffee shop, and then we extract all those information based on the key values. Like what do we want to get? We want to get type, ID, name, and brand, and also the lat and long as coordinates, right? And then we manually collect those information and throw them into a new dictionary. And that new dictionary is going to be one record in the target data frame. Okay, questions? Let me know if you have any questions. Let's move on to implement it. Okay, so what do we do? So it's going to be slightly tedious, but bear with me. So we can let's complete this task together. Okay, so let's define a variable called, let's say, cafe list, right? And cafe list is a list, and later on it's going to be a list of dictionaries, right? So it's again a JSON format data set, but it's the cleaned JSON data set instead of the raw data set, which will lead to missing values in the data frame. Okay, so let's define an empty list called cafe list. Okay, now we're gonna iterate over all those entries, but actually I think I should use a new cell because I have some comments directly available. Actually not, that's okay. So let's go back. I'm going to first define this list of cafes. It starts from empty because I haven't done any cleaning yet, right? Haven't done any work yet. Now, then I'm going to do an iteration. So we can say places, for place in places, right? To start a for loop. It means that we're going to iterate over all those records inside the JSON data set. Right? Remember, the JSON data set is a bunch of cafes, so basically we're going to go through every single cafe inside that list of places. Okay. Now, what do we do next? So Gemini is giving us some hints, but let's do something that's slightly different. So let's say the type of the place, so place underscore type, or any other possible choice of name would be fine. So we're going to do place type, but let's do place.get type, which is the same as using square brackets, but just in case sometimes the keys don't exist, we don't want to get an error. Okay. So that's the type, and then as you can see, Gemini is hinting that you can similarly obtain the ID of the current cafe you are looking at, right? And that's ID. So we can do tags, right? So we want to get the tags, all the tags for the current coffee shop in each of the iterations. So we can do that. I think we probably don't need the last bit. I mean, it's the same. It doesn't matter. So tags equal to place.get tags. So that's getting the bunch of information under the tags key for a certain cafe, right? So then name and brands, and they are all hidden under the tags key. Now we can get names, right? Name is equal to, so the name of the place is equal to tags. So it's a nested structure, and the name information is hidden under the content corresponding to tags, right? And then we can see that, let me just use the tab key on my computer to, accept the hint by Gemini. So nothing fancy, right? So just we're getting brand and cuisine style. Those are all information hidden or nested under the tags key of the original dictionary. Okay. Now, there's different treatment for node type places and weight type places, right? So again, to be more efficient, and you can do the same thing if you are following along. Let me just accept the Gemini's hints. So if the place type is actually a node, we just get the latitude and longitude directly based on the keys lat and long, because they are directly key entries inside the dictionary. If not, let's say else if, ELIF is else if it's not node, instead it's way, right? We can only first get the center point of the place. My center is actually another key inside the dictionary if the type is way, right? And then the latitude and longitude is hidden or nested under the center entry inside a dictionary that's representing a two-dimensional shape, which is considered as a way inside OpenStreetMap, right? So anyways, those are not super important in my opinion, but then they are somehow necessary, right? So finally, we're gonna do one more thing. So let's say we have the cafe list, right? Cafe list started from an empty list. So in the beginning, there's nothing there. But as we iterate over all those cafes in the list, in the original JSON data set, we can add those data records after cleaning one by one, right? So what do we do is that we're gonna append records to the cafe list. But what do we append, right? So it's round brackets, that's representing a function, the append function. But what do we append? So let's make it a bit more actually readable by writing the function across several lines, right? So type, what is the type? Well, we actually extracted the type, and that's inside the variable called place type, right? Let me just accept the hint by Gemini. So the name ID of this current record is just stored in place ID and the name variables. What else? Name, ID, those are available. Remember, we want to get the latitude, longitude, and cuisine and brand, right? So with the AI assistant, things are actually quite efficient. So basically, we look at the record in the original data frame, right? And then we extract the different piece of information inside that record and give it a name and store it in a certain variable. And then in the end, we're actually defining a new dictionary. So let me add the curly brackets. So the curly brackets to bind all those extracted information into a new dictionary, right? So from the beginning and the end of this pair of curly brackets, we're including all those key values and the corresponding contents that is already extracted, right? And then I put this new dictionary into the append function. So the new dictionary will be added to the originally empty list of cafes. Okay, so that's what we want to do. Questions? Let me know if I need to slow down slightly. But largely, don't worry too much about this. Like, so first of all, as you try to understand the idea, there's a lot of hints provided by the AI assistant. Or, if you are already clear with the objective, the target, which is to extract all those attributes from the original data set and construct a clean data frame, you can also use the AI assistant to generate the draft code for you. Okay, so after this whole bunch of operations, we'll be ending the for loop. Right? After the for loop ends, I want to actually let's actually quickly visualize the list of cafes, or cafe list, and that is the variable name of the list of cafes after extracting the key piece of information to form a cleaner data set, right? So let's do this, and then let's run it to see what happens. Now, as expected, it just gave us a list of dictionaries, right? Each dictionary is corresponding to a coffee shop, a cafe. And it's smaller than the original dictionaries because we only focused on certain pieces of information. And in that way, it is supposed to be cleaner, right? So now, it's a better looking, actually, JSON format data set, right? And the name is cafe list. Right? So the list of dictionaries, each dictionary is a cafe. Now, let's see what we can do next, okay? Let's see what we can do next. So we can do pd.dataframe to construct a data frame based on the new list of dictionaries. So it's called cafe list. And we can quickly see. And now this time looks quite nice, right? There's no missing values. So, and it looks like we indeed get whatever we wanted. Like we have ID, name, latitude, longitude, and the cuisine type, and the brand name. I mean, we still see some missing values. For example, for the second row, we don't have the cuisine type or the brand, but that's natural, right? Because real life data can be somehow messy, and particularly this cafe may not be belonging to any retail chains, so that it doesn't have a brand, right? And the owner or the users may not have provided a particular information about the cuisine style, and that's okay. But anyways, in general, I think it looks much better, right? So it's almost missing value free. It's highly structured. And our task for this part is basically complete, but to quickly conclude, let's actually give it a name. Let's call it df cafes, because I want to store this data frame in a variable. So that's the name I came up with. You can use another name if preferred. And then the last thing is that once again we can do df cafe. This time let's use the head function to just look at the first 5 rows. If it looks okay to you, this time we're going to do df cafes dot to CSV. So we want to convert to a CSV file for our next step of analysis. Right? You can call it cafes.csv or any file name you want to use. Index equal to false as usual, because we see the indexes on the very left. Right? I don't want to store them as a separate column in my CSV file. Right? If you want, you can do so, but usually it's not necessary. And let's do that. No error. And let me switch to the notebook view and click on the file, the folder icon, and you can see that the cafes.csv file is created, right? And if you want, you need to download it, right? Because it's only a temporary file stored in your runtime storage. After your notebook got disconnected with the Colab server, it will be deleted. Right? So if you want to keep it, you can download it. For me, I have already downloaded and I have prepared it for the next step of use. Anyways, so that's something we did. It's again somehow mostly focusing on how to manipulate data set, but the new feature is that now we can get JSON data from a server, from an API service, and then we did a bit of a cleaning. Okay, so one main purpose of introducing the tools for analyzing JSON data is precisely that many API services will give you this kind of data format. Questions? Okay, that's great. Now, we still have some time before the second break, so let's carry on. Okay. Now, moving back to Avenue quickly, so this part is completely finished. We're finally starting the next module, which is visualization. It's going to be shorter than the data preparation session module, because as you know that part is serving as a fundamental piece for our course and some of your projects, so we spend more time on it. But visualization, we're going to focus on the key tools and key ideas. We're trying to use a more pragmatic approach, right? First of all, we're trying to use simple Python calls to develop different types of charts in different contexts. And then I'll try to show you a quick demonstration of how to turn your pictures or charts into an app where everybody can access as long as they can access the internet. Okay? So let's start from, I already went over quickly the slides, right? Let's start from this first notebook here. And this time we're gonna work again on the data we obtained and cleaned from the OpenStreetMap API, and then we'll create some visualizations from there. So let's open this notebook, and on my end, I will also try to launch this new notebook. It's a different file. So allow me a few moments to open the visualization notebook. So let's see if it's the right file. All right, so this is the first part of visualization, and our focus is only on the data set we obtain. Okay, and this part I want to show you a scatter plot, and not only the scatter plot, but we including as a map as the background image, right? Because that's typically what map-based apps actually provides, right? So let's see how we can do that. So we're going to use the Plotly library, which is to create interactive visualization, all different types of charts where you can hover your mouse to get information or click buttons to perform certain tasks, right? Two main modules inside the library. We're going to focus on the second one, Plotly.express, because it's high level. By high level, I mean that there's a lot of automation behind the scenes. As a result, it's much easier for us to use than the lower level libraries. Okay. So start from installing Plotly. Well, for Colab, Plotly is actually included without installation. But in this example particular, I want to install it again. That's because we're going to use the newer version. As you know, the Colab may not always provide us with the latest version, and it happens that it is the case that we want to use some features of the newer version, right? So this is something I commented out earlier, but if you want to follow along, you can type this command, pip install Plotly, but there's an argument which is -u. -u means upgrade, right? So there's already a version available, but we want to update it into the latest version. Okay, and then let's click on it, and it takes a few moments to warm up, and then it may take like some time to install, but it's, the downloading is very fast. As you can see, it found a I think maybe, so it identified the version of the Plotly installed already on Colab. It's 5.24.1, but then we removed it and installed the newer version, which is 6.3.1. Okay, so, and that's because we're going to use the newer functions to be more efficient and to have the results look nicer. Okay, now we're going to use the previous data set, but if you didn't save it, that's okay, because I saved it and uploaded it into a public repository, and you can right-click on to get the link, to copy the link of this data set in the format of CSV file, and we're going to do the usual thing to actually load this CSV file using pandas as a data frame, right? So what do? So we're going to import pandas as PD. We cannot do much if we don't use the pandas library whenever we need to deal with data frames. So let's create a data frame from the CSV file. That's the usual thing, pd.read underscore CSV. Inside the underscore, provide the link to the CSV file, right? So remember, I already copied the link. So let me just do Control V to paste the link. Okay, so that's the link, and then we can preview the data frame, and that's something we have been doing for many times. So, and that's what we get, right? So what we are looking at is a data frame, and that data frame is precisely the one we obtained by the end of the previous notebook. Nothing new, different coffee shops in Toronto. And now I want to show them on a map, right? So let's imagine that you are developing an app, right, that allows people to search. Let's say they want to search for like coffee shop or parks or other places on the map, and then they can enter the information, and you should return the information as a visualization chart on the map, right? So before we move on to creating the map, let's quickly consider how to construct scatter plot without any mapping background. Okay, so it will be highly similar to the one with the map background, except that in many cases the latter may look nicer. But as just to warm up, let's just try to do it. So this is the syntax of the Plotly Express module. So we're going to use the scatter function to create a scatter plot using the Plotly.express module, right? So it has a bunch of input requirements. Some of them are required, some of them are optional arguments, right? So this is the sort of the syntax or the format for you to use the function. And I included a link to the documentation of Plotly, but in general, I think it's easier for you to ask ChatGPT or Gemini. But in any case, here our purpose is to, get our hands dirty to create the visualizations. Okay, so let's get started. Let's not worry too much about the syntax, because we are gonna see how we can do it together. So let's import the Plotly library, and specifically we're going to import Plotly.express. We're going to use the express module inside the Plotly library. Usually we call it PX. Like pandas we call it PD, and Plotly Express we call it PX. Okay. Now I'm going to create a figure. Let's call it fig. I mean, you can use other names. You can call it figure 1, figure 2, or simply a figure or something, or a chart. Any name of the variable. But what do we do? We're going to do px dot scatter. And there are, as hinted by Gemini, there are three required inputs, right? First of all, the data frame, because we're plotting based on a certain data set. So we need to tell which data frame to use. Right? So it's DF, the data set we imported from the CSV file. And then for a scatter plot, we have to include all those points in the plot. How do we define the points? Well, we have the coordinates, right? So basically what we want to do, let me try to see if I can draw something on the web page to illustrate the idea, right? So what we want to do is to create a plot. Usually the plot will have the x-axis and the y-axis, right? And then we need to include every point. Each point, as you can imagine, represents a cafe, okay? But how do we detect, for example, we have a point here. How do we decide the location of that point corresponding to a cafe? Well, it's the x is the latitude value, longitude value, right? It's longitude value. And y is the latitude value. So for every cafe, we got the longitude and latitude, right? And we specify that the longitude will be used as the value for the x-axis, latitude will be used for the value of the y-axis, and then that basically defines a point. Right? Now, of course, we don't just include one point. Instead, we're going to include all those different points. Right? Anyways, if you provide all those information, the data set, and x and y, and x equal to y equal to, those two arguments will require you to give the function the name of the columns. And remember, we have a long column and a lat column from the data frame from here. So there's a latitude column, longitude column, and then we're going to say that the longitude values will be used as the x values. Latitude values will be used as y values. And that's enough, right? And eventually we need to, usually it's a good idea to include this function, fig.show, to show the figure, okay? So this is a minimal example. Let's run it first, and then we're gonna and then we're gonna look at it and before we make it more rich, right? So as we can see, there's no map background because this is simply a scatter plotting function. So the x-axis will be the longitudes of all those locations, and the y-axis will be the latitudes. And then if you hover your mouse over any one of those points, it will tell you, the longitude and latitude. Those are precisely two pieces of information you provided to the function, right? So that's the sort of the minimal graph we can produce. And often we want to make it nicer, but how do we make it nicer? So for functions, we can actually enter all those arguments across different lines just to make things more clear. Okay? So we just include more elements. For example, after providing the latitude as the y value, what we can do is that we can do title equal to a certain title you want to use, right? So it's like cafes in Toronto. So that will give a title to the chart you're going to use. Okay, so that's the cafes in Toronto. And now, one more thing we can do is about the information shown on the chart when you hover your mouse over the points, right? So right now, you see long and lat, those are, acronyms, right? Which may not be super intuitive. So let's say we're gonna do labels equal to a dictionary format, but long is going to be mapped into longitude, the full name, right? And then the second entry will be lat inside, the quotation marks for dictionaries, and we can call it latitude, include the full name. Okay, so let's run it. So first of all, we have a title, right? And then when you hover it, it's not showing you long equal to something, lat equal to something, but it's longitude and latitude. So basically, we want to make it more intuitive for the labels. We are renaming the labels, right? And we can also include something called hover underscore name equal to, let's do name. I mean, what does it mean? Name is a column, right? Name is a column in the data set. If you quickly go back, there's a column called name, right? By doing so, I'm specifying that when I'm hovering over a point, not only I want to show you the longitude and latitude by default, but also show me the name of the coffee shop, of the cafe, right? So those are just a bunch of additional arguments we can use, optional but additional. Sorry, I think so between every pair of arguments, you have to separate them with comma. So adding the comma, and then same plot, right? It has a title, and if you hover your mouse, now other than longitude and latitude, you can see the name of the coffee shop. For example, this point is a Tim Hortons coffee shop, and if you go back, right, so it's you're using the information in the name column by specifying hover underscore name equal to name. Okay, so that's how we can create a scatter point, right? So almost time for the second break, but let's try to do one more thing before before we start the break. Okay, it's not gonna take a long time, but instead we're gonna create a minimal example where not only we have the scattered points representing different cafes, but this time let's add a map background. Right? Let's see how we can do this. So we're gonna do fig equal to px, that's Plotly Express, right? And then we're gonna do scatter, again scatter, but then we're gonna do scatter underscore map. Okay. Inside the map, we're gonna create include similar information. First of all, data frame is df, right? And then in the scatter plot, we have x and y being specified as 2 columns in the data frame. Okay, and this time, if we're using scatter map, scatter points across a map background, let's do. It's actually not x and y; it's directly called lat and long. So latitude, lat equal to the lat column in the data frame, right? And longitude, long equal to long in the data frame. Okay, so for the minimum setting, I think that's enough. Let's see how it works out. I mean, if you run it, nothing shows up because you have to do, you define it, you create a figure, and then it's stored in the fig variable. It overwrites the previous fig variable, but you have to use fig.show to show it. Okay, so this is what happens. Still scatter points, but then by using scatter map, you are including the map background. And what's nice about Plotly is that you can use your mouse, use the scrolling feature, of your mouse to just scroll it, and you can also move it around, right? So that's what is available through a high-level library. We didn't ask for it, but they are just automatically included. So we have created the visualization, but it's a minimal example. We only provided the information to this scatter map function, and only 2 pieces of information are included, which is latitude and longitude, right? So let's make it more rich this time. So for example, one thing we can do is that we can use different colors for the different points, right? Of course, if we use different colors, then each color may be representing a particular subset of the coffee shop, right? So let's quickly go back to see the columns of the data set, right? So we have all those different pieces of information, and this time let's focus on brand, right? So there are different brands, as you can already see. There are Tim Hortons, Starbucks, Second Cup, among many others. So how about we use different color to represent different brands? Okay, so let's see how we can do that. So only one more argument will be sufficient. So we do color equal to brand, and the value of this color argument must be a certain column in the data frame, right? And then if we don't get any surprises, we will be able to see the different colors representing different brands of coffee shops, right? So for example, let's pick a green point, it's Tim Hortons. Blue point, that's Second Cup. A purple point, that's Starbucks. Okay, I mean, by default, the box that shows up when you hover the mouse over the point is also having the same color. Okay, and on the right-hand side, as we can see, we now get a legend to explain the color code for different types of brands. Okay, now that's one thing I believe to be quite nice, because it's nicer or more clear than just a bunch of points on a map with the same color. This time it's more informative, right? What else we can do? Now, if you hover your mouse over a point, originally, before we only have latitude and longitude, right? Now we have the brand, and that's because we have passed the brand information as a column through the color argument. So now explicitly we're passing latitude, longitude, and color. So when you hover the mouse over a point, all those 3 pieces of information will be shown. Okay, but we didn't see information in other columns. Right? For example, cuisine and name. Name is also not there, right? Because it's a brand that is included. Name is not included. So let's try to include more information in the box that shows up when you hover your mouse over certain points, right? So as before, let's do a title, Cafes in Toronto, and hover name equal to name. That's the same as the previous chart. So let me run it to update the chart, right? And Now this time, when you hover your mouse, the name shows up on the top of the box because we said hover name equal to the column that contains all the names of the different cafes, right? So then we also have a title for this plot, cafes in Toronto. There's a way to put the title in the center, but let's not worry about that for now. We'll leave that for later, right? So one more thing to do is that I can include more information in the box for hovering, right? So what we can do is that we can do hover data, and in this hover data argument, we can include more pieces of information. We can provide a list of column names, right? So let's include more column names. So one is the brand, that's already included through the color argument, but let's include it again nevertheless, right? So let's also include cuisine. If you want, you can also include things like, let me check what other columns are there available. Not much, but if you want, you can do type, because remember we have node and way to represent different coffee shops. So let's say we also include type, and then let's run it. No difference, but if you hover your mouse, right, the displayed information becomes richer, right? So we have cuisine and type, right? So that's just a simple way to add information to the box that shows up when you want to hover your mouse to get information. All right. So there are many other things we can do. So let's try one thing that may be somehow useful for controlling the format of the visualization chart, right? So one thing useful is to specify the size of the chart, right? So let's say width is equal to let's say 1,000. So I think it will become wider, and height equal to, let's say, 800 or maybe 600 to make it somehow a bit like a short rectangle. And let's run it. So there's sorry about the error. Again, it's about forgetting a comma. Right? Actually, the size of the plot is different, and then also what we can do in addition is that, for example, we can specify the zooming level, right? Let's say zoom equal to 11 or 12 or anything you want to use, and then run it again. You will see that the default zoom scale is different. Right now it's more zoomed in, right? If you change it like to let's say smaller value, 5, then it's more zoomed out, right? So I mean, those are not so important because you can always use the interactive features provided by the chart to zoom in and zoom out. But sometimes it's also nice to have a default zooming level. Right? And what else? One thing I want to demonstrate is that let's go to the next screen where I have provided a list of styles, right? So by default, this is kind of a default map styles, not too different from what we see in like maybe Google Maps or Apple Maps, right? But let's say we can actually specify the styles. For example, there's a style that allows you to use the satellite view style. Let's copy this, and then going back to the function, let's include one more argument, which is called map style equal to satellite streets. Okay, so let's see how it becomes different. So it's just a satellite view, satellite style for seeing it's the same. The cafe is on the same chart, right? So you can do your own experiments. There are different types of map styles. You will see different types of backgrounds for the map. Anyways, so that's just something we can manipulate. Okay, so that's how we can create a scatter plot on top of a map. Right? And one more last thing I want to quickly demonstrate. This time, let's not spend too much time on it. First of all, I want to go back and then copy this. Copy this whole function we just used. And one more feature is that we can actually create. Let's remove some of those comments. Create animation instead of a static plot, right? So basically nothing too complicated. That's the nice thing about those high-level libraries. So again, I copied and pasted the same codes. I will modify this slightly. And the most important thing, first let me delete the map style because let's still use the default map style. Now, one thing I want to do is that I create a new line inside the list of arguments in this function. And let's do animation. So I want to create an animation this time. So animation frame equal to, let's say, brand. What does it mean? So let me explain what it means. Right? So I want to create an animation. And we know animations are just, frames of pictures, right? So each picture can be a frame, so you're transitioning from one frame to the next frame, so that creates an animation. That's exactly what we're going to do. But you want to show different contents in different frames, right? So what do we show? Going back to this original data frame. So again, we focus on the brand column. As we can see, there are different brands. So how about in the first frame, I only show Tim Hortons. The second frame, I also only show the second cup shops, and the third frame I only show Starbucks. And then we have the same kind of chart, but divided into different frames. Each frame will focus only on one type of brand. Okay, so let's see how it works. So I only added this additional line, and let's see how it works. Okay. So it's I've run the code and then scrolling down to see. Let me also actually delete the zooming level because it's too zoomed in, I believe. Okay, so I think actually instead of deleting the zooming level, let me specify zoom equal to something intermediate, right? So maybe something like 8. And scrolling down, we can see it. Maybe a bit more zoomed in, 10. Just to make it look nicer. Okay, so that's what we see here, but there's a button there. If you click on the button, you will see that it's switching between frames, right? So first it shows second cup, and then as the progress bar moves forward, it's actually iterating over different coffee shops, right? So let me actually exit the slide mode, so hopefully we can see better. And so pay attention to the legend on the right-hand side. So you will see that the brand is changing, right? Every time it's showing one particular brand. Now, so basically I think that serves the purpose, right? So I actually, when I see this, I felt that something is not perfect because as you can see, when you are switching between those frames, the map is shifting left and right a little bit, right? So basically, it's moving. It's ideal that things don't move, like the background, at least the background don't move. Only the points will show up and disappear, switching to the next set of points, right? So that's actually took me a bit of time to find out why, but turned out, as you can see, the legends to indicate the brands of the coffees, turned out the width is different between different types, right? Because some of the brands have longer names, some of the brands have shorter names. So in order to overcome this issue, it's not super complicated, but let me quickly include a few lines of code. So this time I'm going to include another function called fig. This is the figure we created, and that's the whole figure is stored in this variable called fig. I'm going to do fig update layout, and that's a function. And inside the function, we can include arguments to specify, how we want to control the format. And this time, I want to control the legend. So legend, and usually for the plotting functions, oftentimes we use a dictionary to control the different attributes of the plot, right? So let's do several things. I'm going to actually move the legend from left to the top, right? Because if it's on the left, it actually affects the width of the plot, which is not super nice. So I want to move it to the top. How do I move it to the top? Well, moving to the top is actually determined by the position along the vertical axis, y-axis, right? So then what we want to do is that, let's say, I'm defining something called y-anchor as an argument. Okay? And here it's bottom, because the legend is basically something like an invisible, it's not invisible, it's a box with invisible borders, right? So now I want to focus on the bottom of the legend part, and then I want to specify the location of the bottom of the legend box, legend rectangular area. So let's focus on the bottom of the legend, and so that's why we said y anchor equal to bottom, right? And then let's specify y equal to 1.02. If it's 1, and then it's at the same level as the top of the plotting area, but I made it 1.02, slightly above 1. So we're moving the legend slightly above the plotting area. So that in that case, the legend will show up above the plotting area. So I think that's basically enough. There's a bunch of more things you can do, but let's just for our purpose of stop the animation from moving the mapping background from side to side. I think that should be okay. So let's see how it goes. Now, so basically, there's sorry, I should use, for dictionaries, don't use equal, instead use column, right? So let's see how it goes. Slight y anchor is not defined. So anyways, so I'm not sure how where the error. Let me just use the explain error function again. Sometimes the small details are really hard to figure out. So let me just cheat a little bit here to get this out of the way. Oh yeah, so I forgot the quotation marks. So y anchor and y, those are attributes, should be inside quotation marks. And then now I have accepted the suggestion by Gemini, and then let's see it again. So as you can see, that the brand is now above the plotting area, and it's still moving a little bit. So actually, I need to specify the the location, horizontal location of the legend, right? So let's define x anchor. So x anchor should be center. So I want it to be on top of the plotting area, not on the side, so it doesn't affect the width of the plotting area. And x is equal to 0.5. X equal to 0 is that it's going to be placed to the very left. If it's 1, it's the very right. 0.5 means that the legend area will be in the middle. Okay, so then let's run it. And now this legend is on top. And then let's try to do it. Now you can see that as we do the animation, things are not moving from side to side, right? So that's basically how we can create this animation to define frames. Each frame will be a particular brand of cafes, and only showing those cafes. And then when you start the animation, it just goes over all those different types. Okay. Of course, there's much more we can do. So many things are not so nice. For example, the title is not in the center, right? For the legend, if you want, you can make brand actually capitalized, right? Using a specification of the labels in the legend. So there are many things we can do, but in the interest of time, we're not going to spend much more time on this.